The true size of the universe. If the universe were reduced to the size of Earth, everything humanity has ever observed, every star, every galaxy, every signal of light ever detected, would fit inside a grain of sand. And even that comparison still fails to truly describe how vast reality is. Because the universe is not simply large. It is large in a way the human mind was never designed to comprehend. Tonight, we are not talking about planets. We are not talking about stars. We are not even talking about galaxies. We are talking about scale itself. The kind of scale that makes numbers feel meaningless and distance lose all intuition. The human brain evolved to understand space in practical terms. How far we can walk. How far we can see. How long it takes to travel from one place to another. We understand rooms. We understand cities. We understand countries and continents. We even understand Earth as a massive sphere floating in space. But the universe exists on a scale where those instincts completely fail. At cosmic distances, our everyday understanding of size collapses. So to truly understand the universe, we must build it slowly, one layer at a time. Let us begin with what feels familiar. Earth. Earth is about 12,700 kilometers wide. From orbit, it looks complete and self-contained. A blue sphere covered in clouds and oceans. A world filled with motion and life. From the surface, Earth feels endless. Mountains stretch beyond the horizon. Oceans seem to go on forever. But Earth is only the first step. If Earth were reduced to the size of a marble resting in your hand, the moon would become a tiny peppercorn, floating roughly 30 centimeters away. This surprises most people. The moon feels close. It dominates the night sky. But in reality, the space between Earth and the moon is vast. So vast, in fact, that every planet in the solar system could fit between them with room to spare. Now let us add the sun. Scaled to our marble Earth, the sun would be a glowing sphere 2 meters wide, placed more than 100 meters away. Already this feels uncomfortable. Already space feels emptier than we imagined. But this is still only our immediate neighborhood. Beyond the sun, the solar system continues outward. Mercury, Venus, Earth, Mars. Then the gas giants. Jupiter, Saturn, Uranus, Neptune. Each planet separated by enormous distances of empty space. Between these worlds, there is almost nothing. No air, no sound, no warmth, just silence and motion. And beyond the planets, the solar system stretches even farther. A vast cloud of icy objects, comets on orbits that take thousands or even millions of years to complete a single loop. Even here, we have already gone far beyond what most people imagine when they think of space. But this entire solar system, every planet, every moon, every asteroid and comet, is still microscopic. Because the solar system itself is just a tiny dot inside something much larger. A galaxy. A galaxy called the Milky Way. The Milky Way contains over 100 billion stars, each one a sun, each one potentially surrounded by planets, each one a possible center of its own system. If every star in the Milky Way were reduced to a single grain of sand, the galaxy would not fit in a city. It would not fit in a country. It would fill an entire continent. Light, traveling at the fastest speed possible, takes 100,000 years to cross our galaxy from one side to the other. That means when we look at distant stars, we are looking deep into the past. Our solar system sits far from the center, in one of the outer spiral arms, orbiting quietly, largely unnoticed. And yet, as large as the Milky Way is, it is not special. It is not unique. It is only one galaxy among countless others. And this is where our sense of scale begins to truly break apart. As large as the Milky Way is, it is not special. It is not unique. It is only one galaxy among hundreds of billions. When we zoom out beyond our galaxy, we begin to see something even more unsettling. Galaxies are not evenly spread through space. They gather. They cluster. They form enormous structure, held together by gravity. Our Milky Way is part of a small group of galaxies called the local group. It contains dozens of galaxies, each one vast beyond imagination. Some are spirals like ours. Some are elliptical. Some are distorted and torn, shaped by gravitational encounters. Even this small group spans millions of light years. But the local group itself is only a tiny piece of something far larger: galaxy clusters. These clusters contain hundreds or even thousands of galaxies, all orbiting a common center of mass. Distances between galaxies are enormous. Distances between clusters are even greater. Between them lies deep cosmic voids, regions of space almost completely empty. As we map the universe on its largest scales, a pattern begins to emerge. Galaxies form filaments, long thread-like structures stretching across hundreds of millions of light years. These filaments intersect at dense nodes of galaxy clusters, creating something scientists call the cosmic web. It is the largest known structure in the universe, a vast network of matter spanning unimaginable distances with empty voids in between that dwarf entire galaxies. If we could see the universe from far enough away, it would resemble a giant three-dimensional web, with glowing threads of galaxies and immense dark regions between them. And even this is still only part of the observable universe. As we continue to zoom out, individual galaxies vanish into points of light. Clusters blur together. Filaments fade. Eventually, all structure disappears into a faint cosmic glow. This glow is not made of stars or galaxies. It is the oldest light in the universe, the cosmic microwave background. It is the afterglow of the Big Bang itself, released when the universe was only 380,000 years old. This light has been traveling for nearly the entire age of the universe, slowly stretched and cooled as space expanded. It marks the boundary of what we can observe. Not the edge of the universe, but the edge of visibility. Beyond this point, light has not had enough time to reach us. And this is where things become truly strange. The universe is about 13.8 billion years old, yet the observable universe is about 93 billion light years across. This seems impossible. How can something 13 billion years old be so much larger than 13 billion light years? The answer lies in expansion. Space itself is expanding. Not galaxies moving through space, but space stretching everywhere at once. As light travels across the cosmos, the space beneath it expands, increasing the distance between everything. The farther away something is, the faster it appears to be moving away from us. There are galaxies so distant that their light will never reach us, no matter how long we wait. They are already beyond our cosmic horizon. This means the observable universe is not static. It is shrinking, not in size, but in what we can access. Every moment, more of the universe slips beyond reach forever. And yet everything we have described so far, every star, every galaxy, every filament of the cosmic web, represents less than 5% of what actually exists. The rest of the universe is invisible. It does not emit light. It does not absorb light. But it dominates everything. Dark matter. Dark energy. Dark matter acts like cosmic glue, holding galaxies and clusters together. Without it, galaxies would fly apart and stars would never form. Dark energy is even stranger. It pushes space itself outward, driving the expansion of the universe to accelerate. The farther into the future we look, the faster galaxies will recede. Eventually, most galaxies will disappear from view entirely, leaving isolated islands of stars in an ever-darkening cosmos. The universe is not just large. It is dynamic. It is changing. And it is mostly unknown. This brings us to the most unsettling question of all. Is the universe finite? Or does it continue forever? The observable universe has a boundary, but the total universe may not. It could extend endlessly beyond what we can ever observe. Endless space, endless matter, endless repetition. Or it may curve back on itself, forming a closed structure without edges. Or it may end in ways we do not yet understand. Science does not have the answer. Not yet. But the question itself changes how we see everything. Because if the universe is infinite, then everything that can happen will happen somewhere. Every possibility, every variation, repeated endlessly across space. And somewhere, far beyond what we can ever reach, there may be regions of the universe identical to our own. The same galaxies, the same stars, perhaps even worlds remarkably similar to Earth. And this thought leads us to the final shift in scale. To understand the true size of the universe, we must stop thinking only in space. We must also think in time, because scale does not exist only in distance, but in duration. The universe is not frozen. It is evolving. Stars are born. Stars die. Galaxies collide. Galaxies drift apart. Everything is moving, changing, slowly transforming over unimaginable spans of time. A human lifetime is measured in decades. Civilizations last thousands of years. Even recorded history is only a thin scratch on the surface of time. But cosmic time is measured in millions, billions, and trillions of years. Stars like our sun live for about 10 billion years. Massive stars burn brighter and die faster, sometimes in just a few million years. When they die, they explode, seeding space with heavy elements. Every atom of iron in your blood, every atom of calcium in your bones, was forged inside a dying star. On these timescales, creation and destruction are inseparable. But even stars are temporary. Galaxies themselves will not last forever. As dark energy drives the expansion of space faster and faster, galaxies will drift beyond one another's reach. In the far future, most galaxies will disappear beyond the cosmic horizon. Observers in that distant era will see a dark sky with only their local stars remaining. The universe will appear smaller, even though it is larger than ever. Eventually, star formation will slow. Gas will be used up. New stars will no longer be born. Existing stars will burn out, one by one. White dwarfs will cool. Neutron stars will fade. Black holes will remain. For an incredibly long time, black holes will dominate the cosmos. They will merge. They will grow. They will slowly evaporate through a process called Hawking radiation. Even black holes are not eternal. After unimaginable spans of time, they too will disappear. What remains after that is difficult to imagine. A universe filled with cold particles, faint radiation, and near-perfect darkness. This scenario is known as the heat death of the universe, a state of maximum entropy, where no useful energy remains and nothing meaningful can happen. Time itself loses direction. Cause and effect blur. Change slows to a near standstill. And yet, even this may not be the final answer. Some theories suggest the universe could undergo cycles. Expansion followed by contraction. Big bangs followed by big crunches. Others suggest new universes may be born inside black holes, each with its own laws of physics. There may be a multiverse, a vast collection of universes, each one separate, each one real. If this is true, then our universe is just one bubble in a much larger cosmic ocean. And its size, no matter how large it seems to us, may be insignificant compared to what lies beyond. At this point, language begins to fail. Words like large, vast, infinite lose their meaning. The human mind is not built to hold these ideas. And yet, we try. We build telescopes. We build equations. We send machines into space to gather faint signals from the edge of time itself. Not because we expect to fully understand the universe, but because curiosity is part of what makes us human. We are tiny, smaller than planets, smaller than stars, smaller than galaxies. And yet, we are capable of asking questions about the entire universe. From a small planet orbiting an average star in an unremarkable galaxy, we look outward and attempt to comprehend everything. The universe does not care that we exist. It does not notice us. And yet, we exist within it, made of its matter, shaped by its laws. We are the universe, trying to understand itself. So when you look up at the night sky, remember this. You are not just looking at distant lights. You are looking into a structure of unimaginable scale, stretching across space and time, far beyond what the human mind was ever meant to grasp. The universe is not just big, it is beyond scale. And somehow, against all odds, we are here to witness it.